grade 9. In this video, we will be discussing momentum and impulse as part of our fourth quarter module number 2. But before we proceed, let's have first this short activity. So I have here a picture of a truck and a car. So for example, they are moving at the same speed. Let's say they are both moving at 25 meter per second. Which one do you think is more difficult to stop? Is it the truck or the car? Some of you may say that the truck is difficult to stop because it is bigger or it is massive compared to the car. Well, some of you might say that it is more difficult to stop the car because it is smaller, okay, than the truck. Now, we will find out the answer when we proceed with our lesson for today. Another question, which is difficult to stop. Let's say we have two identical tricycles, and tricycle letter A is moving at 20 meter per second, while tricycle B is moving at 10 meter per second. So, they are identical, they have the same mass, but they are moving with different speed. Okay? Which one do you think is more difficult to stop? Some of you may say tricycle A because it is moving faster than tricycle B. Now, let's find out if your answers to these two questions are correct. Now, these questions are related to our concept, which is all about momentum. So, when we say momentum, it is inertia in motion. It tells us how difficult it is to stop a moving object. So the higher the momentum of a particular object, the more difficult it is to stop. And the SI unit used for momentum is kilogram times meter per second or Newton times meter. Okay? Now, these are the formula for momentum. So we have here P, small letter P. This is the symbol for momentum, is equal to M or the mass times V, the velocity. So kung mapapansin natin dito sa formula for momentum, dalawa lang ang factors na pwedeng maka-affect sa momentum of a moving object. So that is mass and velocity. Okay? Now tandaan natin, the bigger the mass of the object, okay, it is more difficult to stop the object. So in our first example, yung kanina, yung truck at saka yung car, okay, the correct answer is the truck. Okay? So dahil mas massive siya, mas malaki siya, mas mabigat, mas mahirap pahintuin yung truck. Okay? Although they are moving at the same speed. Another example, yung kanina, yung dalawang tricycle, they are identical, parehong-pareho, pero they are moving at different speeds. Okay? Now, tandaan natin, velocity is also a factor for momentum. Now, the higher the velocity of a moving object, or the faster the object moves, the higher the momentum. Okay? Now, if ever the problem calls for mass or velocity, so we have here formula number 2 and formula number 3. So for formula number 2, we have mass. So ibig sabihin, mass yung hinahanap natin. So you will be using this formula, P or the momentum divided by V or the velocity. Now if the problem asks for the velocity, okay, so we have here velocity is equal to the momentum divided by the mass. Okay? Now, para mas maintindihan natin kung paano ginagamit itong mga formula na ito, let's proceed with sample problem number 1. So, sample problem number 1, a 2,500 kilogram bus from Tungko moves at 25 meter per second to Palmera. What is the momentum of the bus? Okay, so let's go back to our whiteboard. So in our sample problem number 1, we have there 2,500 kilogram bus. So that is a given quantity. So since the unit is kilogram, therefore it is the mass. So we have the mass, the 2,500 kilogram. Okay? Next, we also have 25 meter per second. Since the unit is meter per second, this is velocity. So you have here velocity is equal to 25 meter per second. Okay. Now, the question is, what is the momentum of the bus? Therefore, we need to find for the momentum or the symbol small letter p. Okay? Now, for the formula, let's check in our screens. Okay, so we have here, we only have three formula for momentum. So you have number 1, number 2, and number 3. Okay, and the formula for momentum is number 1, which is P, or the momentum, is equal to the mass times the velocity. Okay, now, both quantities, mass and velocity, are found in our given. So, nandito na siya sa given natin, di ba? So, diretso na tayo sa solution. So, you need to substitute the given quantities. Okay? So you have here, P or momentum is equal to the mass, 2,500 kilogram, times the velocity, which is 25 meter per second. Okay? Using your calculator, you just need to multiply 2,500 times 25. You will get the answer 62,500. What will be now the unit? The unit will be kilogram, meter per second, or you may also write this as Newton seconds. Okay? So this is now our final answer. Di ba? Madali lang. Now let's proceed with sample problem number 2. Sample problem number 2. How fast a 1,800 kilogram car must move to have the same momentum as the bus in problem number 1. So in sample problem number 2, the given is a car, okay, with a mass of 1,800 kilogram. Okay? Now, the question is, how fast should the car move to have the same momentum as the bus in number 1? So, alam natin yung bus ay mas malaki compared dun sa car. Okay? Pero, pwede sila magkaroon pa rin ng parehong momentum. Okay? Dun nga lang sila ngayon magkakaroon ng adjustment sa velocity. Ang tinatanong dito, how fast, okay, the car should move or its velocity. So therefore, our given quantities are, so we have the mass of the car, which is 1,800 kilogram. And then we also have the momentum. So we have small letter p. Sabi kasi, same momentum as the bus in problem number 1. So that is 62,500 kilogram meter per second. Now, we need to find for the velocity. So we have here v, okay, and then the formula. So we will be using formula number 3, which is v is equal to p, or the momentum, divided by the mass. Okay? Now, for the solution, so isubstitute lang natin kasi pareho namang momentum and mass ay nasa given. So you have here velocity is equal to the momentum, 62,500 kilogram meter per second, divided by the mass, which is 1,800 kilogram. So you just need to divide 62,500 divided by 1,800. So you will get 34.72. Lagi po tayong round off up to 2 decimal places. Now, what will be the unit? So, kilogram, ayan, pareho sila. So, dinivide. So, maka-cancel out yan. We will be left with meter per second. So, this is our final answer. Di ba? Madali lang po. So, just make sure for momentum, alam ninyo kung ano yung mga formula natin. Kasi tatlo lang naman yan. So, we have P is equal to mv, m is equal to P over V, and V is equal to P over. Since we are talking about momentum and how difficult it is to stop a moving object, okay, isa sa mga makikita nating applications of momentum ay itong mga car accidents. Diba? Sabi nga natin, the higher the momentum, the more difficult it is to stop a moving object. So, kapag sobrang bilis ng mga sasakyan, okay? So, sobrang hirap din nilang pahintuin. So, dahil doon, nagkakaroon ngayon ng mga car accidents such as this, kung saan total wreck yung sasakyan. Okay, paano nangyayari, ma'am, na nagiging ganito yung epekto noong momentum doon sa mismong sasakyan? Bakit nangyayari na sobrang sirang-sira naman, ma'am, yung sasakyan after the collision? Dito ngayon papasok ang impulse. Okay, now, when we say impulse, if there is an external force acting on an object over a specific time, it leads to a change in momentum of the object. So, ibig sabihin, kapag impulse, there is a change in momentum. So, kapag nabago yung momentum of a moving object is impulse. And if there is a force acting on an object over a period of time. So, para lang mabago yung momentum of a moving object, kailangan may force acting on the object. Okay? So, pwedeng halimbawa, umaanda rin sa sakyan for 25 meter per second. So, syempre may particular mass na siya. So, automatic meron siyang momentum. Okay? Pero kapag inapakan yung brakes, di ba? Unti-unti nag-slow down yung sasakyan, mababago din yung momentum of a particular vehicle. Okay? Tandaan natin, ang momentum kasi dahil dalawa lang ang factors niya, mass and velocity. Usually, sa mass, hindi naman yan basta-basta nababawasan, di ba? So, sa velocity ngayon, sa pagbabago pa lang ng velocity, whether bumilis or bumagal yung sasakyan, nagkakaroon na ngayon ng change in momentum. Okay? Pero tandaan, nakaspecify po dito sa impulse that if there is a force acting on an object over a period of time, dun lang nababago yung momentum. And pag nabago na yung momentum, we already call that as impulse. And the SI unit for impulse is the same with momentum, which is kilogram meter per second or Newton seconds. Okay? Now, sa impulse or sa change in momentum, meron tayong dalawang dapat tandaan na concept. We have the impact force and the impact time. Okay? Now, tandaan natin, number one, the impact force is small if the impact time is long. So, ibig sabihin, kung mas matagal yung time bago na hit ng object, ay yung isa pang object or bago siya bumangga sa pader or sa puno, okay? Kung mahaba yung time, ay simula nung inapakan yung brakes hanggang sa bumangga siya dun sa puno, therefore, the impact force is smaller. So, ibig sabihin, medyo matagal pa yung time mo bago bumangga, mas mahina na ngayon yung force, impact force na marireceive no object. Number two, the impact force is big if the impact time is short. So, kung halimbawa, sobrang bilis yung sasakyan, tapos ilang segundo lang bumangga siya agad doon sa pader. Okay? The impact time is short. Di ba? Maikli lang. Sobrang bilis lang ng mga pangyayari. Therefore, the impact force is big. Kaya nangyayari ngayon, pagbangga niya dun sa pader, malakas yung pagbangga niya. Malakas ngayon yung sira doon sa sakyan. Kasi yung impact force ay mas malaki. Okay? To further explain this one, let's have some pictures. Ayan. So, this is a picture of one of the boxing matches of Senator Manny Pacquiao. So, ayan. Diba? So, papansin nyo sa boxing, dito, isa sa pinaka-applicable yung impact force at impact time. Di ba papansin nyo, pag naman sumusuntok, di ba, ng mga boksingero, hindi naman slow-mo yung suntok nila, di ba? Kailangan mabilis. Bakit kailangan mabilis yung pagsuntok nila? Para ang impact time, pag tumama sa muka or sa katawan ng kalaban nila, ang impact force ay malaki. Kasi nga, yung impact time nila ay maikli lang. Dahil mabilis nga yung movement, yung impact force ngayon na marireceive, okay, ng kalaban nila ay malaki. Kaya, ang tendency ngayon, mas masakit yung mga suntok. Okay? Compared, syempre, kung slow motion mo, sinuntok. Diba? So, pag ganon, longer yung impact time, therefore, the impact force is smaller. Okay? Another example, ayan, sa ibang sports katulad ng football, okay? Or sa ibang bansa tinatawag din itong rugby. So ito medyo physical sports. Okay? So dito, tumatakbo sila, hawak nila yung bola, so kailangan nilang ibato yung bola sa kabilang field, tapos kailangan ma-shoot din dun sa goal or maipasok dun sa goal nila. Now, ang nangyayari kasi dito, kailangan mapigilan nung kalabang team. Okay? Yung team na may hawak ng bola. So dito may mga tendency na katulad ng nasa picture na nagkakabanggaan sila. Okay? At dahil sobrang bilis ng takbo, okay, nung mga players. So, syempre, mabilis yung takbo, the impact time is shorter, therefore, yung impact force, pag nag-collide na silang dalawa, ay masyadong mataas. Okay? Kaya may mga tendency na bigla rin tumutumba, okay, kapag ka biglang nagkabanggaan sa sobrang bilis. Okay? Nung impact time. Okay? Next example, ayan, another picture. Ayan. So, dito sa picture na to, babangga na ngayon yung sasakyan sa pader. So, ito yung pader. Ayan. So, papasin nyo, kung mabilis yung movement or yung velocity ng sasakyan at maliit lang din yung impact time. So, ibig sabihin, sobrang bilis kasi ng movement sa sasakyan, kaya shorter lang yung impact time. Therefore, mas malaki yung magiging damage sa sasakyan. Kasi mas malaki ang impact force na marireceive ng sasakyan. Kaya dito tayo nagkakaroon ng mga car accidents kung saan total wreck yung mga sasakyan dahil sobrang bilis ng movement nila, ng velocity. Tapos sobrang ikli lang ng time. Okay? Simula nung habang nag-move sila at saka nung bigla silang bumangga. Okay? Kaya sobrang laki ng impact force. Sobrang laki din yung nagiging damage sa mga sasakyan. Okay. Now, this is the reason why seatbelt is made for safety. Ayan. Kaya po sa mga sasakyan, kailangan merong seatbelt. At dapat ang seatbelt, hindi lang yung driver, kundi maging yung mga pasahero. Pero bakit nga ba mahalaga itong seatbelt na to? Tulad ng binanggit natin kanina, kapag kasi mabilis yung movement ng sasakyan, diba? Tapos bigla siyang huminto. Okay? Pwedeng bigla siyang huminto, bigla siyang promeno, or bigla siyang nabangga sa puno, sa pader, or sa isa pang vehicle. Okay? So, dahil mabilis yung movement ng sasakyan, bigla siya nabangga. So, ang tendency ngayon, hindi lang yung sasakyan yung pagkakaroon ng damage, maging yung nasa loob ng sasakyan. Pansin nyo ba kapag sumasakay kayo ng jeep? Diba? Noong mga panahon na sumasakay pa kayo ng jeep, diba? Kapag kaumandar na yung jeep, ang movement ng katawan ninyo, palayo doon sa driver. Diba? Tapos, kapag biglang huminto yung driver, napakabilis ng takbo niya. Bigla siyang huminto. Mapapansin nyo, lahat kayong pasahero, ang movement nyo forward, papunta sa driver. Tama? Okay? Yun ay dahil din sa inertia. Kasi syempre, yung katawan kasi natin, okay, kapag nasa moving vehicle tayo, ang tendency natin, mag-move din according to the direction of the vehicle. Kaya lang biglang huminto. At dahil biglang huminto yung vehicle, so ang tendency ngayon ng katawan natin, hindi siya biglang hihinto. Kaya ang tendency natin, mag-move pa rin tayo according to that direction. Kaya tayo ay nag-move forward papunta dun sa driver. Okay? Kaya mahalaga ang seatbelt kasi kung wala ang seatbelt tapos ang lean forward natin papunta dun sa driver, may tendency na, ayan, ganyan yung mangyari. Okay? Kaya mahalaga po ang seatbelt for the safety of the driver and the passengers. Okay? Lalo-lalo na kung may mga private vehicles kayo, mahalaga yan. Kasi ang ginagawa ng seatbelt, instead na mag-lean forward kayo, mape-prevent niya yung pag-lean forward ninyo. So, nakastay lang kayo doon sa mismong upuan. Now, let's proceed with the formula for impulse. So, we have here 6 different formula for impulse. Kung papansin niyo, tatlo dito ay capital letter I. This is for, the symbol for impulse. So, tatlo kasi yung pwede natin gamiting formula for impulse depending on the given quantity. Okay? So, for number 1, we will be using this if the given is force and time. Okay? For number 2, okay, delta P. This is the change in momentum. So, ibig sabihin, kung parehong momentum ang given, the initial momentum and then the final momentum. So, ang gagawin lang naman natin dito para ma-solve to, you just need to subtract final momentum minus the initial momentum. Okay? Next, number 3 is I is equal to M change or delta V. So, this is the change in velocity. So, kung papansin nyo sa number 6, andito yung formula for delta V or change in velocity, which is the final velocity minus the initial velocity. And then number 4, we will be using formula number 4 if the problem asks for the force. So, how much force is acting on the object? So, this is the formula: mass times the final velocity minus mass times the initial velocity divided by the time. And then we also have number 5, which is the distance. How far did the car travel? Gaano kalayo yung narating ng object? In this formula, we have here distance is equal to time times the initial velocity plus the final velocity divided by. To further understand how we are going to use this formula for impulse, let's have sample problem number 1. So, Tiger Woods hits a 0.02 kilogram ball, giving it a speed of 25 meter per second. What impulse does he impart to the ball? So, let's go back to our whiteboard. Okay, so let's have sample problem number 1 for impulse. So, we have the given quantities. Okay, so you have a ball which has the mass of 0.02 kilogram. So, you have mass of the ball 0.02 kilogram. And then, next we have the velocity, which is 25 meter per second. Next, we need to find for the impulse, which has the symbol capital letter I. Now, for the formula, as you can see, we have 3 different formula for impulse. So, you have number 1, number 2, and number 3. But since the given is mass and velocity, we will be using number 3, which is I is equal to M delta V, or the change in velocity. Now, the problem is we have the mass, but we do not have the delta V or change in velocity. So, as you can see in number 6, we have a different formula for delta V, which is the final velocity minus the initial velocity. Now, let's go back to the sample problem. Ang sabi niya sa sample problem, si Tiger Woods, tinamaan niya yung bola na 0.02 kilogram ang bigat. Now, nung tinamaan niya yung bola, nagkaroon niya ng speed na 25 meter per second. Ang tanong ngayon dito, etong 25 meter per second na to, is it the initial velocity or the final velocity? Now, tandaan natin pa naglalaro ng golf. Kasi si Tiger Woods ay sikat sa golf. Okay? Pag naglalaro ng golf, initially, yung bola ay nasa sahig lang. Okay? So, ibig sabihin, hindi siya gumagalaw. It is at rest. Now, tandaan natin, if the ball is at rest, therefore, it has no velocity. So, the initial velocity is 0. Okay? Now, nung hinampas niya ngayon yung bola, nagkaroon ngayon ng speed yung bola. Nagkaroon siya ng velocity. Now, the velocity is 25 meter per second. Therefore, the final velocity in this problem is 25 meter per second. Okay? Nakakasunod po tayo, ha? So, we have here delta V. So, the final velocity is 25 meter per second minus 0 meter per second. Okay. Now, since 0 naman yan, so pag minus natin 25 minus 0, you will still be getting 25 meter per second. Nagkataon lang kasi na yung initial velocity natin is 0 kasi nagsimula at rest yung object. Pero kung sakaling may movement na yung object tapos biglang nagbago yung velocity, so syempre kung ano yung unang velocity, usually that is the initial velocity. Tapos kung ano yung panghuli, that is the final velocity. Okay. Now, we already have the delta V. So, pwede na nating sagutan yung nasa formula. So, for the solution, you just need to substitute. So, you have I is equal to the mass, 0.02 kilogram, times the delta V or the change in velocity, which is 25 meter per second. So, I is equal to, multiply lang po natin, 0.02 kilogram times 25. You will be getting 0.5 or 0.50. The unit now will be kilogram. Tapos, huwag kakalimutan yung dot ha. Kilogram meter per second or Newton seconds. This is now our final answer. Now, kung sakali halimbawa na ang given ay force and time, you will be using formula number 1. If the given is both momentum, we only have the initial and then the final momentum, ang gagamitin naman natin ay yung formula number 2. Next, let's have sample problem number 2. A 2,250 kilogram car traveling westward is slowed down uniformly from 20 meter per second to 5 meter per second in 4 seconds. How much force is acting on the car? So let's now have sample problem number 2. So for the given, we have the mass of the car, which is 2,250 kilogram. Now, ang sabi kasi dito, yung car ay nagta-travel westward. So, maandar siya. Pero it's slowed down. So, bumagal yung sasakyan. So, from 20 meter per second to 5 meter per second. So, kung bumagal siya, ibig sabihin, initially, mabilis yung sasakyan. So, our initial velocity is 20 meter per second. And then, our final velocity is 5 meter per second. Sabi dito, it only took 4 seconds nung nag-slow down yung sasakyan from 20 meter per second to 5 meter per second. So you have here the time, which is 4 seconds. Now, we need to find for the force. How much force is acting on the car? So, isa lang naman po ang formula natin for force dito sa topic na ito, which is number 4 in your screen. So, you have here, force is equal to mass times the final velocity minus mass times the initial velocity divided by the time. Okay? So, check natin. Lahat ba nung nasa formula ay given na quantities? So, we have the mass. Check. So, we have the final velocity. We have the initial velocity. And then, we have the time. Therefore, pwede tayong magdiretso sa ating solution. Okay. So, first, let's substitute the given quantities. We have force, okay, is equal to the mass. We have 2,250 kilogram times the final velocity, which is 5 meter per second, minus the mass again, 2,250 kilogram, times the initial velocity, 20 meter per second. Yan. Divided by the time, which is 4 seconds. Okay. Now, isa-isahin natin ha. You just need to multiply first. So, mumultiply muna natin 2,250 times 5. So, 2,250 times 5. So, 2,250 times 5, you will get 11,250. The unit now will be kilogram meter per second. Minus this one, 2,250 times 20. So, you will get 45,000. The unit now is kilogram meter per second, divided by the time, which is 4 seconds. Now, you need to subtract 11,250 minus 45,000. So, you will get negative 33,750 kilogram meter per second, divided by the time, 4 seconds. Okay, so last step, you need to divide. You will get the final answer, negative 8,437.5. The unit now will be kilogram meter per second squared, or simply Newton. Okay, So this is now our final answer. Now, tandaan sa force, okay lang po yan kung negative yung force. Kasi dito nga ay nag-slow down yung object. Diba? So, okay lang po yan kung ganyan yung inyong sagot. And tandaan, ang unit for force is kilogram meter per second squared or Newton. Kung nahabaan kayo dito, you may just simply write capital letter N or Newton. Next, for the last part of our discussion for today, we have law of conservation of momentum. So the law of conservation of momentum states that in the absence of an external force, the momentum of the system remains unchanged. So ibig sabihin, kung walang external force by acting on the object, yung momentum ay hindi mababago. So walang may iba doon sa momentum of a particular object. Now, this is an example to show the law of conservation of momentum. So, dito sa picture na ito, ayan, ito yung unang scenario. So, silang dalawa ay skaters. Okay? So, ayan, meron silang shoes for ice skating. Now, tinutulak nila yung isa't isa. Okay? Now, ang tendency, pagtulak nila ngayon dun sa bawat isa, when they push each other, okay, ang mangyayari ngayon, makikita ninyo yung scenario number 2, in which they both move backwards. Okay? So, ibig sabihin, equal yung momentum nila, therefore, pareho ngayon yung movement nila, pero in opposite direction. Okay? Now, to further discuss about this, so we have here the general formula for law of conservation of momentum, which is the total initial momentum is equal to the final initial momentum. So meaning, kung ano yung initial momentum of the object, yun din yung magiging final momentum nila. So dapat equal lang siya. Kaya nga siya tinawag na conservation of momentum. Walang pagbabago sa momentum nilang dalawa. Okay? So for this particular formula, we have here the M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. Okay? Kung saan ito po yung maibig sabihin ng mga may number na yan. So M1 is the mass of the first body or first object. M2 is the mass of the second body or second object. V1 initial is the initial velocity of the first body or first object. V2 initial is the initial velocity of the second body or second object. And then V1 final, final velocity of the first body. And then second V2 final is the final velocity of the second body. So, kaya pa ba? Grade 9. Yung mga nauna nating computations for momentum and impulse ay medyo mas madali. Dito, mas mahaba yung computation na gagawin natin. So, this is the last topic in our discussion for today. So, please bear with me. Okay? So, let's have one last example problem. Okay? So, isang sample problem lang po tayo for law of conservation of momentum. So, let's have the sample problem. So, a 0.02 kilogram ball moving to the right at 0.25 meter per second makes an elastic head-on collision. So, nag-collide yung bola sa isang 0.04 kilogram ball moving to the left. Okay? At 0.15 meter per second. After the collision, the smaller ball moves to the left at 0.16 meter per second. Now, the question is, what is the velocity of the 0.04 kilogram ball after collision? Medyo magulo ba? At medyo masakit po ba sa ulo? So, isa-isahin natin. Okay? Let's go back to our whiteboard. So, para maintindihan natin yung nasa sample problem for conservation of momentum, i-drawing natin yung scenario. Okay? Sabi kasi dito, meron tayong bola. So, may bola. Halimbawa, ito yung 0.02 kilogram ball. Okay? Tapos, ang sabi dito, ito ay gumagalaw, moving to the right. There's the right. Okay? Tapos, ang kanyang velocity ay 0.25 meter per second. Okay? And then, may isa pang bola. Di ba nagkabanggaan nga silang dalawa. So, yung isa pang bola, ang kanya namang mass ay 0.04 kilogram. Okay? And it is moving to the left. Kaya nga sila nagkabanggaan kasi opposite direction. Okay? Head-on collision yung naganap. So, ang kanyang velocity naman ay 0.15 meter per second. So, ito ay yung initial. Okay? So, you have the mass of the first object. Ito yung unang object natin. This is the initial velocity. Yan, pinaikli ko na lang para magkasya. So, this is V1 initial. And then, this is the mass of our second object. And this is the V2 or the initial velocity of the second object. V2 initial. Ayan. Okay? So, ayan na po yan. So, this is initial. Now, ang sabi dito, nagkaroon sila ng collision. So, nagkabanggaan yung dalawang bola na yan. Now, after ngayon ng banggaan, yung smaller ball ay nag-move papunta sa left. Okay, which at a speed of 0.16 meter per second. So, ulitin natin, ang smaller ball is the first ball, which is 0.02 kilogram. So, ito daw ngayon, after the collision, nag-move na siya papunta sa left. Okay? So, ang kanyang final velocity, so, V1 final, lagyan ko na lang letter F, which is 0.16 meter per second. Now, ang tinatanong ngayon, itong velocity nitong pangalawang bola. What is the velocity of the second ball? Final velocity of the second ball. So, yun po yung ibig sabihin nung nasa problem number 1. Okay. Now, ilagay ngayon natin sa formula. Okay, yung ating nasa given. Binura ko lang, no, kasi medyo maliit yung aking whiteboard, hindi magkakasya lahat. So, we have here, check nyo yung formula dyan sa nasa screens. So, dediretso na ako ngayon ng solution. Okay? So, we have here the mass, which is a mass of the first object, which is 0.02 kilogram, times the initial velocity of the first object, which is 0.25 meter per second, plus the mass of the second object, which is 0.04 kilogram, times the initial velocity of the second object, which is 0.15, is equal to the mass of the first object, 0.02 kilogram, times the velocity of the final velocity of the first object, which is 0.16 meter per second. Okay? Medyo dito na lang sa gilid yung mamaya naman ay mapapalit natin yung nasa formula. Plus, we have the final, the mass of the second object, which is 0.04 kilogram. And dahil lang hinahanap po is the final velocity of the second object, yun yung matitira. We have here V2 F. Yan, pasensya na, medyo tagilid na siya, no? Kasi malapit na siya sa gilid ng ating board. So, isa-isahin po natin. Unahin natin part by part. So, ito muna yung compute natin. So, 0.02 kilogram times 0.25. Yan. So, actually, the answer is 0.005. Since sobrang liit niya, hindi na natin siya i-round off to 2 decimal places. Okay? So, 0.005. So, this is kilogram meter per second. Plus, ito naman kasunod. So, you just need to multiply 0.04 times 0.15. So, you will get 0.006 kilogram meter per second. Ayan. So, okay na tayo dyan, no? Is equal to, so ito naman yung kasunod. 0.02 times 0.16. So, you will get, again, dahil sobrang liit ng mga values, Kokopyahin natin yung lahat. Wala tayong i-round off, okay? 0.0032. So, same unit, which is kilogram, meter per second. Plus, kokopyahin nyo lang ulit ito. Okay? So, hindi ko na isusulat ha. Medyo kulang tayo sa space. So, mangyari, after nyo makompute to, kokopyahin nyo ulit yung 0.04 times V2 final. Okay? After that, let's proceed. Ito muna ang part na to. So, you just need to add 0.005 plus 0.006. So, you will get 0.011 kilogram meter per second is equal to, dito sa part na to, kokopyahin lang natin to, yung buong side na to sa kaliwa, sa kanan rather. So, you have your 0.0032 kilogram meter per second plus 0.04 kilogram times the final velocity of the second object or V2 final. Okay. Okay na tayo dito. So, ano na pong kasunod na gagawin, ma? Since ang hinahanap natin ay nandito sa side na to, ayan. So, ang gagawin natin, tatranspose natin ito dito sa kabila. So, we have here 0.011 kilogram meter per second minus 0.0032 kilogram meter per second equal to 0.04 kilogram times V2 final. Okay? So, next step na po ngayon, i-minus, subtract muna natin to. So, you have 0.011 minus 0.0032. So, you will get 0.0078 kilogram meter per second. So, equal to, kopyahin nyo lang to ulit, 0.04 kilogram. Tapos, V2 final. Now, to get the V2 final, kailangan matanggal natin tong 0.04 kilogram. So, ano pang gagawin? You need to divide both sides by 0.04 kilogram. So, 0.04 kilogram. So, maka-cancel out to dito. Ang matitira ay ito, V2F. Okay? So, we have here V2F or the final velocity of the second object. So, ito na ngayon ang gagawin natin. Last step, you need to divide. So, we have 0.0078 divided by 0.04. So, you will get now 0.195. Cancel out yung kilogram. Ang matitira ngayon nating unit is meter per second. So, this is your final answer. Kung mapapansin ninyo, mahaba talaga yung pagsusulat sa solution for conservation of momentum. Okay? And then, after ninyong ma-identify lahat, okay, nung mga kailangan sa formula, kailangan nyo muna part by part na sagutan. So, katulad nito, balikan natin. Ito, minultiply natin to get this one. Tapos, ito ulit, multiply, para ito naman yung sagot. Tapos, ito ulit, multiply. Okay? Once na multiply nyo na itong dalawa, in-add natin to get 0.011. Tapos, ito, kinopya lang natin. Since nandito yung kailangan nating part, okay, na ma-identify o makuha natin yung sagot, tinranspose natin sa kabila itong 0.032. So, pag transpose, syempre maging negative yung sign niya. So, we have your 0.032. Okay, minus na. So, minus natin yung 0.11 sa 0.0032 to get 0.0078. Okay? Since kinopya natin to ulit dito. Since ang hinahanap natin is V2F, ito lang dapat yung may iwan na quantity. So, yung katabi niya, which is 0.04 kilogram, divide natin both sides by 0.04 kilogram para ma-cancel out. And then, matitira natin is V2F. And then, your final, okay, final operation, you need to divide. So we have 0.078 divided by 0.04. So you will get the final velocity of the second object, which is 0.195 meter per second. Medyo nahirapan po ba? Ako, I personally believe medyo mahirap po talaga itong conservation of momentum. Pero I hope dun sa first two parts natin kanina, the momentum and impulse, medyo nadalian naman kayo, no? In any case, if you have further questions, you may rewatch our video lesson para mas maintindihan nyo po ulit kung paano ginawa or sinolve yun nasa sample problems. Okay, so for this week's activity, you just need to answer our fourth quarter quiz number 1 in Google Forms. So kindly wait for the link of the Google Forms. And then, sa ating quiz din, you need to use the code collisions. So tandaan tong code natin collisions, pati yung pinaka-spelling niya and kung paano siya sinulat. Okay? To get bonus points. So pag ginamit yung code na ito sa ating quiz number 1, meron kayong bonus points na makukuha. Okay? Thank you for watching grade 9. I hope you have learned something for today. Medyo may mahirap na part sa ating discussion. So if you have any other questions, you may chat in our Facebook group chat or comment in our Facebook